entire planet. We're talking about volcanoes. Now, I know you've seen the pictures, right? The glowing lava, the massive ash clouds, but today we're going to unpack the incredible hidden mechanics of how these giants actually work. Where does all that liquid fire even come from? And how do they literally reshape the world we live in? We've got a fantastic set of slides lined up for you, so let's get right into it. But before we go deep underground, let's actually start right in your kitchen. Have you ever boiled tea or maybe made a pot of Maggi noodles on the stove? I want you to picture this right now. You've got a pot of water on high heat and you place a heavy metal lid right on top. What happens when it starts to boil? Well, the steam starts rising, right? But the lid is blocking it. So the pressure just builds and builds until finally that metal lid starts rattling and shaking and the steam literally forces its way out through the sides and gaps. It absolutely has to escape somewhere. Okay, let's dive into this, because that simple kitchen pot is exactly what's happening on a massive planetary scale beneath our feet. Our Earth's crust is kind of like that heavy metal lid. It's a hard, non-conducting layer. But deep down, intense heat generated by radioactive materials creates what geologists call endogenic forces. This incredible heat melts the rocks into a highly pressurized, super hot liquid. Just like that steam trying to push past the lid, this trapped pressure pushes against our Earth's tectonic plates, desperately searching for a gap, a crack, or a weak margin to finally burst through. Our Earth is, quite literally, a giant geological pressure cooker. Section 1. Anatomy of an eruption, from the deep. So the crucial point is understanding exactly what we're looking at when an eruption actually happens. People mix these two terms up all the time, but the distinction is actually very simple. It's all about location. When that superheated molten material is trapped way down deep inside the Earth's magma chamber, we call it magma. It's essentially the same stuff, but it's grounded, it's under immense pressure, and it's hiding in the dark. But the very second that magma finds an opening, what we call a vent, and blasts its way out onto the surface of the Earth, boom, its name changes to lava. So magma is inside, lava's outside. And let's see how this builds over time, because a volcano definitely isn't built in a day. It's a spectacular cycle of creation that takes literally millions of years. First, the hot liquid lava erupts from the vent, and sometimes it blasts out with these shattered rocks called volcanic bombs. Then, that lava flows outwards, it cools down, and it turns into solid rock. After that, the volcano kind of goes quiet until the next eruption. Lava flows out over the old rock, cools, and hardens again. Layer by layer, eruption after eruption, this repeating cycle slowly stacks up to form those massive, iconic, cone-shaped mountains we all instantly recognize. Section 2. The life cycle. Active, dormant, or extinct. Now, what's really interesting about this slide is seeing how we categorize these phases, because like we said, this process takes millions of years. Volcanoes aren't just erupting 24/7. We've got active, dormant, and extinct. Active volcanoes like Mount Etna, well, they're the extroverts. They're erupting frequently right now, in the present day. Then we have dormant volcanoes. These are our sleeping giants. Take Mount Kilimanjaro in Africa, for instance. It hasn't erupted in recent historical times, maybe for thousands of years. It's sleeping, but it could wake up. Finally, we have extinct volcanoes like Mount Kenya. These are the ones where the engine has completely died. Their underground magma chambers are totally empty, and they're highly, highly unlikely to ever erupt again. Section 3. Builders and destroyers. The duality of volcanoes. While we almost always view active volcanoes as destructive monsters, let's actually look at their hero arc first. Look at all the magnificent things volcanoes actually build. When thin lava flows out and spreads over massive distances before cooling, it forms these perfectly flat, elevated lands called plateaus. India's rich peninsular plateau is a great example. Continuous lava flooding can create vast, super fertile volcanic plains. Sometimes, an eruption is so violently powerful, it blows the entire top of the mountain right off, leaving a massive crater. Over time, rainwater fills this up, creating these beautifully serene caldera lakes. My personal favorite, when underground water systems get heated by that deep magma, we get glorious hot springs and gushing geysers. They literally sculpt some of our planet's most beautiful landscapes. But of course, we absolutely cannot ignore the villain side of the story. The immediate destructive effects of an eruption are just staggering. We're talking about the total annihilation of life and property in the immediate vicinity. Entire agricultural fields can be buried under feet of thick, suffocating volcanic ash, rendering them completely useless. But beyond the lava and the ash, there's this terrifying invisible danger. You see, the magma deep within the Earth is packed with highly toxic gases. When a volcano erupts, it releases massive plumes of sulfur dioxide, nitrogen monoxide, and carbon dioxide. These poisonous gases can cause severe health crises for miles and miles around, long after the lava has stopped flowing.
Section 4. Where do volcanoes hide?
So, where are all these giants hiding? Well, a staggering 80% of the world's active volcanoes are clustered in one specific massive zone. And this brilliantly illustrates the Circum-Pacific Belt, or as it's much more famously called, the Pacific Ring of Fire. It's this enormous horseshoe shape that wraps right around the edges of the Pacific Ocean. Because this is where several massive tectonic plates meet, collide, and actually slide under one another, it creates the absolute perfect breeding ground for those endogenic forces to break through the Earth's crust. But wait, it's actually not just oceanic borders. There's another major zone called the Mid-World Mountain Belt. What's really incredible here is that these active volcanoes are hiding right in the middle of continents, like deep inside continental plates, rather than just on the ocean's edges. A perfect example of this is Mount Stromboli, which furiously vents its pressure right out of the continental crust. It just goes to show that no matter where you are, if there's a crack in the Earth's plate, that pressure cooker is going to find a way to let off steam.
Which brings us to our final provocative thought for today. We've talked about global plates, the Ring of Fire, and these deep continental belts, but let's bring it local for a second. Did you know that India has exactly one single active volcano? It's located out in the Andaman and Nicobar Islands, just quietly venting, waiting for its next moment. But here's my challenge to you. Do you know its name? Think about it, do a little digging, and drop the exact name in the comments if you know it. Thank you so much for joining me today to unpack the awesome, terrifying, and beautiful science of volcanoes. Keep learning, and I'll